Good morning, everybody. Today is Friday. It's Friday, September 22nd. That was silly. Sorry about that. Listen, we picked up where we left off yesterday. We're in Geology on Mars, lesson 1.2, starting with activity 4, and we're going to observe the surface of the Earth. So if you were in periods 1 and 2 and you were here yesterday, you can kind of fast forward through this part. If you were in periods 4, 5, and 7, we did not get to this part, so you need to stay and listen. And I'm just going to summarize, okay? So we want to take a closer look at different types of landforms formed by flowing water and flowing water on Earth. So I'm going to kind of just preview a couple things here. This is an example of a landform that was formed by flowing water. Remember, landform is a feature that forms on the surface of a rocky planet, and it's caused by a geologic process. So geologic process such as flowing water or flowing lava. All right, so we've got water and then we've got flowing lava. So I gave the kids 2 cards and they spent some time talking about what they see and describing what they see. And specifically in lesson 1.2, activity 4, on screen number 2, you've got a data chart. And there's this word bank that I want you to use. So that way we're all using the same language. And you're going to describe the shape of the landform formed by flowing water and flowing lava. So I just had, my slides are messed up. So I showed this picture here and I said, okay, guys, what do you see? And we started talking about the words in the word bank. So obviously the word curvy came up really quickly because of the river in Africa there on the left. And then we also talked about deep versus shallow. So on the right, you can see the Orange River in South Africa. We definitely have very steep riverbanks, cliffs almost. But then as you continue in that picture on South Africa, if you continue to follow the river up towards the top of the page, you can see that that deep canyon structure, landform on the sides kind of goes away and it's just more of a flat river. And then as it goes into the mountains in the distance, it might do the same thing and cut through there again. But we just talked about that. That was kind of interesting. We talked about how some sections of the rivers are curvy, but then some sections of the same river are actually straight. So if you look at the Orange River in South Africa, this section right here at the bottom of the picture is relatively straight. And then you go around a curve. And then you go around another curve. But if you look at it from the bottom right to the top left, I mean, it's almost, it could be, you could say it's curving, but it's going in the same direction, so it's kind of going in a straight line. If you look at the river or the landform in the top middle section, we also see that they branch and that they actually merge as well. So those are words that we wrote down. And the bottom river, the river in the mountains of Russia, we can see that it's narrow and it's wide. It just sort of depends on where in the river. So some parts are narrow, some parts are wide. We also talked about how some parts are like that we would consider gnarly. Like that is a gnarly landform. It's not smooth. It's very bumpy and gnarled. So write all of those words down in that first box. And then when we compare that to the geologic process of flowing lava, you can see that there's some similarities here. And there's some differences too, but there's a lot of similarities. Like in the picture in Hawaii on the left, that looks really similar to the picture of the Orange River in South Africa, doesn't it? It's curvy in some places and straight in other places. The lava flow in the bottom center from Mexico, that is gnarly, right? That's gnarly. It also merges and branches. And the lava flow in Japan above that, if you can look at the very top, you can definitely see where some of those lava flows branched out and then came back together and merged back together. And the reason why we have this like triangular shape or kind of circular shape at the end is because we know, according to physics, the laws of physics, that water, well, really any fluid, is going to flow downhill. So we know that the elevation for this lava flow, it's higher as it's coming down, and then it's pooling because the elevation is flattening out. And if that happened, I'm going to show you this picture. Look at the Orange River in South Africa. Pretend at the very end of that, so up kind of in the top area, pretend that the land is, the elevation has kind of flattened out. What would happen to all that water? Well, it would pool. And what would it make? It would make a lake. So that's a round or a circular feature, landform, right? We're not just talking about what does the river look like, but we're also talking about what do the landforms look like. Look at the landform in Botswana on the left. Yeah, we look at the river and that's curved, but also look at the landform of the circular pond there, right? So we've got curved, straight, definitely gnarled, branching, and merging. So we've got the same kind of words describing both of them. And this is important because when we look at key concept number 2, it says when landforms on different rocky planets look similar, it's evidence that they may have been formed by the same geologic process. That's so important. Make sure that you are understanding this. When landforms on different rocky planets look similar, it's evidence that they may have been formed by the same geologic process. In other words, if we look at a landform on Earth and we say that was formed by flowing water, and we see another landform on Mars and we're like, hey, that looks very similar to what I saw on Earth. If I know it was formed by flowing water on Earth, then I can assume that it was formed by flowing water on Mars. It's the same thing because they're both rocky planets. Very important key concept. So now think about the processes that form the landforms that we just observed. And now look back at the channel on Mars. We just had a really quick discussion about whether we thought this channel on Mars looks similar to any of the landforms that we observed on Earth. And the kids always said, yeah, it does. It very much does look like those landforms. And I took a quick poll and I just asked the kids, what do you guys think? Do you think that it looks more like, actually, let me go back here. The two possible claims for how this channel formed was that it either formed by flowing water or it formed by flowing lava, because we can see the similarities between landforms on Earth and the channel on Mars. We don't know yet which one it is. And in fact, I took a poll and I asked the kids, and I'm not going to tell you what the result was because I don't want to sway your own opinion. But, you know, maybe you're like, I don't know which one it is yet. I need more evidence. And you're right. We do need more evidence to decide which claim is stronger. Based solely on the aerial photography that we saw of Earth that so far, there is support for both claims. And so if you've got support for both claims, it's not really good evidence. It's pretty weak evidence. So we definitely need some more. I wanted to go back here real quick and talk to you about this key concept one more time. I'm hoping that you remember that you're using your key concepts to explain why the evidence that you use to support your claim makes sense. So this is a really good one because you could say, well, I think claim number 1, water formed the channel on Mars. And you would say, because it looks like, you know, we've got similar landforms on Earth, I could come to you and I could say, well, great. That's what's going on Earth, not on Mars. If you use this key concept to explain, then you kind of shut me up. Because basically what you're saying is, hey, if we know that if a landform forms from a certain kind of geologic process, like flowing water, and it looks the way that it does on Earth, I know that I can say that's probably the same thing that happens on Mars, because they're both rocky planets. It's an excellent way to explain your evidence. So please be sure that you are studying your vocabulary and your key concepts. We're finished with chapter 1 now. We're getting ready to move on to chapter 2 on Monday. So make sure that you're studying, make sure that you're staying caught up, and I hope to see you Monday.